Hi to everybody. I wish you all a good day. So today we are going to see our next lecture, that is electrical stimulation of the carcass. In this lecture, we'll be seeing the low voltage and high voltage electrical stimulation. So in the previous lectures, we have seen the mechanism of muscle contractions, and in the conversion of muscle to meat, we have seen the stages of rigor mortis. Then we have seen about the calpines and the cathepsins, how they bring tenderization of the meat. And we have seen about the aging of the meat, in which we have dealt with the wet aging and the dry aging. To understand today's lecture, it will be better if you go through my previous lectures on the topics I have told now. So that will make you understand this topic better. So let's brush up what we have studied in the previous lectures. So in the muscle contraction, we have studied that two things are very important. One is the ATP and another is the calcium ions. For the muscle to contract, ATP is required and the calcium ion is required. The source of ATP is the energy source which is stored in the muscle in the form of glycogen. So during the anaerobic glycolysis, the glycogen will be converted into ATP. And we know that calcium ion is stored in the sarcoplasmic reticulum. The calcium ion is released from the sarcoplasmic reticulum under two conditions. One is during the stimulation of the nerves. So when the nerves get stimulated, the muscles will get stimulated. So during that time, the calcium will be released from the sarcoplasmic reticulum. Another conditions where there will be more calcium ion will be released is that when the muscle is exposed to a temperature less than 15 degrees centigrade, there will be a release of calcium ions from the sarcoplasmic reticulum. This is because at the low temperature, there will be a disruption of the sarcoplasmic reticulum will take place. So the sarcoplasmic reticulum will not be in position to hold the calcium when we expose the muscle to temperature less than 15 degrees centigrade. The disruption will keep on increasing when we go lower and lower temperature. It means that the disruption at 0 degree is more than compared to that of 15 degrees centigrade. So whenever we expose the muscle to less than 15 degrees centigrade, there will be release of calcium ions because of the disruption of the sarcoplasmic reticulum. So just remember this point or keep this point in your mind to understand the further explanation. Next point that you have to keep in your mind is the stages of rigor mortis. So in the stages of rigor mortis, we know that there are 4 stages. One is the delay phase, then the onset phase, then the completion of rigor mortis and resolution of the rigor mortis. So what is delay phase? So when there is plenty of ATP in the muscle, it will get complexed with the magnesium and the muscle will remain in the relaxed state. That is, no cross bridge will be formed between the actin and the myosin. So when the ATP store is more, the delay phase will be more, or delay phase will be longer. That is what happened in the acid rigor. When the glycogen resource is more in the muscle, more ATP will be generated. So this prevents the permanent cross linkage between the actin and myosin. On the other hand, if the glycogen resource is less, as we can see in the case of DFT meat, dark firm and dried meat, the glycogen resource will be less, because when you put the animal under stress. We will be discussing about that in detail in the coming lectures. So there it is an alkaline rigor. So in the alkaline rigor, the delay phase will be less, because the ATP, there will not be sufficient ATP, glycogen will not be there. So naturally the ATP formation will be less. So the onset of rigor will be faster. Is it clear? So after the delay phase, so generally the delay phase will continue in the normal carcass or normal animal. The delay phase will continue up to the pH of around 6 to 6.2 like. Okay. So up to the this pH, that is between 6 and 6.1 or 6.2, the delay phase will be continue. You know the normal muscle pH is 7.1. During the anaerobic glycolysis, the pH decreases because of the accumulation of the lactic acids. So when it attains the pH of around 6 or 6.1, there is the shifting from the delay phase to the onset phase. At this condition also, the ATP reduction is almost come to the 15% of its normal value. So once the ATP is reduced, you know that there will be a permanent cross linkage will be forming. So at this stage, that is at the pH of around 6, almost the ATP is exhausted, or it comes to around less ATP will be there, then the onset of rigor will be taking place. So it will be it will be losing the extensibility because of the permanent cross linkage that will be formed. At the completion of rigor mortis, that is almost 100% of actin and myosin will bind together. So it gives a very rigid structure, or the sarcomere length will be decreased to a great extent. So the meat will be appearing tough at this stage. So it has completely lost its extensibility at the completion of rigor mortis. But there is a accumulation of lactic acid will be there. So the pH will be decreasing. As the pH is decreased, the calcium will be released. Okay. So since the calcium is released, we have seen that the calpains became active. So calpains will act in the process in bringing the resolution of rigor mortis. So again the meat will become tender. So this we have seen already during the conversion of muscle to meat. I have told just to brush what we have studied in our previous lecture. So up to delay phase, it is a pre-rigor. Then it enters in the rigor meat, where it will lose the extensibility and it will become tough. Then in the post-rigor, again there is a resolution of the rigor mortis and the meat will become soft. So remember here, the onset of rigor take place at a pH of around 6 or 6.1. So this is a second point that you have to keep in mind when we go through this lecture. So the tenderness of the meat is affected by the three things we can say. One is the genetic factor, which is beyond our control, and it contributes around 20 to 30% for the toughness or the tenderness. Then the environment, and environment means the management, the type of nutrition that we give, all this be affecting the tenderness. And the third is processing induced toughness. The processing induced toughness plays a major role in the tenderization of the meat. The processing induced toughness, we can control it. So if you are not doing the processing under proper conditions, then it can lead to the toughness of the meat. So under that, the processing induced toughness, we will be dealing the heat shortening, cold shortening, and the thaw rigor. So what is heat shortening? So we are already told that the onset of rigor, so you can see at the onset of rigor start at the pH of 6. But when the pH is 6 and the temperature of the carcass is between 35 to 40, then we come across the heat shortening. That is, at high temperature, the pH is reduced the high temperature of the carcass, at the high temperature of the carcass, the pH is reduced to less than 6, which leads to the heat shortening. So let's see when it occurs. The temperature of the muscle or the carcass is about 35 degrees centigrade at the onset of rigor. So two things is important. The temperature is above 35 and the pH is 6. When you attain the pH in this of 6 is attained in this temperature, then it leads to the heat shortening. So if the carcass temperature is high, when the carcass enter the rigor, that is the pH of around 6, then the hot shortening or the heat shortening may result. This is mainly seen in the tropical countries. When they do the hot deboning, they'll be exposing the meat to a temperature of 30 to 40 degrees centigrade. So at this temperature, the rigor mortis will be faster. So the pH can fall very rapidly to 6. So that can lead to the heat shortening. So what is the problem with the heat shortened meat? That meat will be tough. There will be excessive drip will be coming out of that meat, and the color is pale in color, which is not attractive. So this condition will be somewhat similar to that of the PSA, pale, soft, exudative. Okay, but the meat there it will be soft, here it will be tough. Next condition is the cold shortening. So when the cold shortening will take place? If the carcass temperature falls too quickly, if the carcass temperature falls too quickly before the carcass enter the rigor, onset of rigor, okay, that is here the pH will be more than 6, but the carcass temperature is reduced to less than 15 degrees centigrade. In that conditions, we come across cold shortening. So we can say that when a pre-rigor meat, that is, it has not entered into the rigor, that is, its pH will be more than 6. When pre-rigor meat is exposed to temperature less than 10 to 15 degrees centigrade, then it leads to the cold shortening. Why it leads to the cold shortening? So as I already told in the previous slide, when you expose the meat or the muscle, pre-rigor muscle, less than 10 to 15 degrees centigrade, there is a disruptions of the sarcoplasmic reticulum will take place. The calcium will be released, and I told that it's a pre-rigor meat. So naturally the ATP resource or the glycogen resource will be there. So the ATP will be there. So these two factors will lead to the toughening of the meat. So here, what is the problem? The muscle shortening is more than 40 to 60%. So it will be in the range of 40 to 60% shortening will be taking place. That is, the sarcomere length will be reducing. So this meat is tough on cooking. It's almost irreversible. We cannot, once it became tough, we cannot make it tender. Again, it will be having the drip, excessive drip will be there, and the meat color will also be pale, which will not be attractive. So that is the cold shortening. Then what is thaw rigor? When the pre-rigor meat is exposed to the freezing temperature, so normally we say less than minus 10 degrees centigrade, what happens is the sarcoplasmic reticulum is disrupted completely, and the more calcium will be released. So such meat upon thawing, so during freezing nothing is happening, only the disruptions of the sarcoplasmic reticulum is taking place and the calcium will be released. But upon thawing, what happens is, you know that since it's a pre-rigor meat, there is sufficient calcium, sufficient ATP, and the large quantity of calcium is also released. That again lead to the toughness of the meat. What is the problem? The muscle shortening in the case of thaw rigor is around 60 to 80%. So normally we can come across around 60 to 80% shortening. Shortening means the sarcomere length will be reduced. That is, actin and myosin binding will increase, or they became, two is line come closer to each other. Naturally, that meat will also be more tough. When you compare to that of the cold shortening, thaw shortening is very severe, and you can feel the meat is very tough. That is what we find that in some hotels when we go, we find the meat is very tough like a rock. This is because they bring the pre-rigor meat and immediately they put it in the freezer. So that leads to the thaw rigor. So again, it is irreversible. It is very tough on cooking. It is also, the color will also be pale in color, and there is an excessive drip will be formed. So that is the disadvantage of thaw rigor. So let's, before entering into our today's topic, that is electrical stimulation, let's see how the electrical stimulation works. So this is the thing that the stimulation that we do in the buffalo. So this stimulator is fabricated in the meat technology unit. Locally we have fabricated that. So we are just stimulating the buffalo. So after the bleeding is done, then we give the stimulation. Again, I'll be explaining this in detail in the coming slides. So you can see the blood is just pouring out. You can see the intensity as the time goes, the contraction or the intensity of the contraction is decreasing. So when there is more glycogen, in the initial, in the beginning we have seen that it is having more severe contractions, but it's decreasing, you can see here. It is slowing down. The glycogen resource is utilized. So that is what is happening when you do the electrical stimulation. So the research work showed that the target of 15 to 35 degree at a pH 6 for the optimal tenderness of the meat. So the pH should be attained, or when you attain the pH of 6, the temperature of the carcass should lie between 15 and 35. If it is pH, if the temperature is more than 35, it leads to heat shortening. If the temperature of the carcass is less than 15 degrees centigrade, it leads to cold shortening. So we have to attain a pH of 6 between these two. That is what we do in the electrical stimulation. So electrical stimulation can be used to ensure that the carcass enter rigor at the desired temperature. So what the electrical stimulation is doing here? Electrical stimulation can be used to ensure that the carcass enter the rigor. Okay, rigor means the onset of rigor, which takes place at a pH 7 at the desired temperature. What is the desired temperature? It should be between the 15 and 35. As already told, if it is more than 35, when you are attaining the pH 6, it leads to heat shortening. And if it is less than 15 or 10 degrees centigrade, it leads to cold shortening. I hope it's very clear what the electrical stimulation is doing. So electrical stimulation can be used to ensure that carcass enter the onset of rigor, that is the pH of 6 at the desired temperature, that is between 15 and 35. That is, we are attaining the pH of 6 in the temperature between 15 and 35. I hope it is very clear. So how we can define electrical stimulations? So we have seen that what is happening during the electrical stimulations. So we can define electrical stimulation as a process involved passing the electrical current, that is electrical impulse is passed, okay, through the carcass of a freshly slaughtered animals to use up the energy reserves in the meat. So you know that energy is reserved in the form of glycogen. So when you give the electrical stimulation, we have seen that clipping also, the muscle is contracted and relaxed. So the glycogen will be utilized. So the ATP resource will be reduced. So why we give electrical stimulation? The answer is to fasten the onset and the resolution of rigor mortis. So this will fasten the onset and resolution of rigor mortis, thereby reducing the processing time and labor and plays a vital role in improving the meat tenderness and other meat quality traits. So it will improve the meat quality, it fastens the tenderness process. So object is why we have to go for electrical stimulation. It is rapid chilling. So if you want to, you know that we have to reduce the temperature as quick as possible so as to prevent the microbial load or prevent the microbial multiplications. So we have to rapid chill it. But when you rapidly chill it out, what happens? It leads to cold shortening or the thaw rigor. So here the pH will be reduced very rapidly by using the electrical stimulation. So that will help in the rapid chilling. So after the pH of 6, cold shortening will not take place or the thaw rigor will not take place because there is no sufficient ATP. So this objective is it helps for rapid chilling soon after slaughter so as to prevent the cold shortening and thaw rigor. Another is hot deboning without the loss of meat quality. So what is hot deboning? In another lecture, I'll be talking about that in detail about the hot deboning, its advantages and disadvantages. So if you want to implement the hot deboning, we have to go with the electrical stimulations. So just remember, it is for rapid chilling, so that will help to prevent the cold shortening and thaw rigor. Another is hot deboning. Then that coming to the mechanism of electrical stimulation. So what is happening during the electrical stimulation? How it is reducing the pH or how it is utilizing the glycogen? Let's see. Okay. So when we give the electrical current or the electric pulse through the carcass of freshly slaughtered animals, it leads to repeated contractions and relaxation. Why it is called freshly slaughtered animals? That is, immediately after the exsanguination or after the bleeding, in the case of low voltage electrical stimulation, which we are going to discuss, that we should do within 15 to 20 minutes. Preferably within 10 minutes we have to do it. Okay. So now maximum we can go up to 15 to 20 minutes. And in the case of high voltage, we have to do the stimulation. We have to give the electrical stimulation within 30 to 60 minutes. The most optimum is 30 minutes. So once you give the electrical stimulations, you know that since there is no, it will be shifting to the anaerobic glycolysis. So it will accelerate the postmortem glycolysis or the rigor mortis. So for the anaerobic glycolysis, the glycogen resource will be utilized for the formation of the ATP. So there is a rapid depletion of the muscle glycogen and the ATP will fall down. When all the ATPs are utilized, it will get into the onset of rigor mortis. So here we can also see that during the anaerobic glycolysis, we know that there is accumulation of lactic acids. So the pH will also falls very rapidly. So here you can see the pH, normally the muscle pH, immediately after slaughter, if you see in the meat technology we have done works, we have seen that pH of the muscle, in the case of buffalo, cattle, it's around 7.1 to 7.2 like, and the pH will fall when you give after the electrical stimulation, the pH will come to around 6.4 or 6.5 like. Okay. Within 2 to 4 minutes, we can see. Okay. Within 2 to 4 minutes. Generally, low voltage electrical stimulation we give for 4 minutes, high voltage we give for 2 minutes like. So within this short period, the pH will come to around 0.6 to pH will come to around 6.5. So there is a 0.6 to 0.4 reduction in the pH within a short time. So that is called as a delta pH. Okay. So at the onset of the rigor mortis will take place around, that is the onset, I told you it takes around, the pH will be attaining around 6.5 or 6 like, it takes around 4 to 6 hours. But we attain the 6.5 within 1.5 to, we attain the onset of rigor mortis within 1.5 to 2 hours. Is it clear? So yeah, the research work showed that the target, by electrical stimulation, the target pH of 6 can be attained at a temperature of 15 to 35 degrees centigrade. That is what we are achieving by the electrical stimulation. How? The two things are taking place. One is the delta pH. So sudden drops in the pH from 7.1 or 7, the pH will drop to around 6.5 like, okay, here within 2 to 4 minutes. If it's a low voltage electrical stimulation, it takes 4 minutes. If it's a high voltage electrical stimulation, within 2 minutes, it will fall to around 6.5 or 6.6. Then further drop in the pH. Okay, further drop in the pH is also very rapid compared to the non-stimulated carcass. So within 1.5 hours to 2 hours, we will attain this pH of 6, and during this time the temperature of the carcass is generally, we noted that it is between 15 to 35 degrees centigrade. Normally we can see at 30 degree centigrade we will be achieving this pH of 6. So the combined effect, that is delta pH plus the rate of pH, that is after post electrical stimulations, the pH drop will also be very rapid. So this combined effect is that the muscle enter rigor mortis before the muscle temperature falls to a value, producing cold shortening and toughening. So let's see how the electrical stimulation and pH fall related. Okay. So what is delta pH? The fall in the pH immediately after the electrical stimulation is called as delta pH. So there is a sudden drop in the pH because of the rigorous contraction and relaxation. The muscle glycogen will be utilized and the lactic acid will be formed. So the pH will decrease. So normally the delta pH is it ranges from 0.6 to 0.4. Okay. Then after that, further reduction in the pH, that is post-stimulation rate of pH fall, is about twice as fast as non-stimulated one at a given temperature. Is it clear? So two things is happening. One is sudden drop in the pH, that is called as delta pH. Another is after the stimulation, the pH will fall very fastly than compared to the non-stimulated one at a given temperature range. A mean pH value of 6 was reached at about 1.5 to 2 hours, but normally it takes around 5 to 8 hours in the non-stimulated carcass. So now I hope it is very clear line. Okay, so within 1.5 to 2 hours we will attain a pH of 6, but normally it will take around 5 to 8 hours in the beef carcass, or even it goes up to attain this pH, it even goes up to 12 hours like. Okay, so that is the advantage of electrical stimulation. Sudden drops in the pH, or it will fasten the rigor mortis. So here you can see electrically stimulated, the pH falls very rapidly. Non-stimulated carcasses, you can see it is falling very slowly. Okay, the ultimate pH will fall around 24 to 48 hours like it will take, but here it will be very short. In short time we can attain the ultimate pH also. So how electrical stimulation, so next let's see how electrical stimulation bring tenderness or prevent toughness in meat. So three theories are put forth. Okay, so here we can see the stimulated meat. The brown color is the stimulated meat. You can see that the rapid drop in the pH within 1.5 hours and 2 hours. The pH, the onset rigor pH is attained faster. But here you can see that at the pH of 2, at the time 2 hours, it is still in the 6.6. So it takes more time to attain this pH. And the ultimate pH you can see around 5.8 or 5.6. It taking around 24 hours to 48 hours in the case of cattle. In the case of sheep and goat, it takes around 12 to 24 hours. But here you can see it is attained very fast. Very fast you can attain this. Around 6 to 8 hours you can attain this pH. But here you can see at 6 to 8 hours it is still in the 6.5. So here we can see there is a rapid fall in the pH, plus after the electrical stimulation, the fall in the pH is also very rapid. But here you can see the pH is falling down slowly and the temperature is also decreases. Temperature also will decrease slowly. But here the pH falls rapid, but the carcass temperature will also be higher, say above 30 or about 30. So this will favor to prevent the cold shortening. So electrical stimulate accelerate ATP depletions, resulting in the prevention of cold shortening, making ATP unavailable for the muscle contraction during cold storage and improved tenderness. So one theory is it prevents the cold shortening on thaw rigor. Another is rapid decline in the muscle pH. That's what I do, rapid decline in the muscle pH while the carcass temperature is still high. So we attain this pH say around 6. Normally we have seen that in our meat technology also the temperature of the carcass will be around 30 degrees centigrade. Okay, so at this pH and this temperature of the carcass, the endogenous enzymes That is, the calpines and cathepsins will also be more active, and they bring more action on the muscle protein, and it helps to bring the tenderness, more tenderness of the meat. Third is, during the muscle contractions, we have seen there is a violent contractions and relaxations will be there. Because of that, it leads to physical disruption of the muscle fibers. The muscle fibers will be disrupted, and the muscle internal structure of the muscle will be torn, and this also break the lysosomes also. So cathepsins will also be released, and calcium will also be released. So these enzymes will become more active, and not only that, there is a disruption of the muscle fibers, or the internal structures of the muscles will be broken down, and that will also help to tenderness. So three principles are involved. One is it prevents the cold shortening. Another is it reduces the pH rapidly, but the carcass temperature will be high, say around 30. So at high temperature and at low pH, the calpines and cathepsins will be more active, that bring more proteolytic degradations of the muscle fibers, so the meat will become more tender. Another is during the violent muscle contractions, there is a tearing of the internal bindings, so that will also lead to the tenderness of the meat. So these are the three principles, or how the electrical stimulation bring tenderness, or it prevent the toughness in meat. So let's come to the electrical parameters of the electrical stimulators. So this, what you are seeing here, it is fabricated locally in the meat technology unit. So we gave the specifications and we fabricated that locally. This will cost only 21,000 rupees, and we also gave to some people, some meat processors also. They are also using this our thing. But when you go for the imported one, it will cost around 1 to 1.5 lakhs, like a food company or the Jarvis. It will be costing very high. So we can locally fabricate it. So when you are going to locally fabricate, what are the specifications we have to take care? So one is the frequency. The normal frequency that we can use is 9 to 16 pulse. That normally we go with 14.28 pulse per second. So that is the pulse we can use. And the optimum pulse width, it is 20 to 40 millisecond we have to use. What is the stimulation duration we have to keep? It is 2 minutes for high voltage electrical stimulations. Okay, it depends. Okay, high voltage electrical normally we do for 2 minutes. Low voltage electrical stimulations, approximately 4 minutes we do the low voltage electrical stimulations. So how it works? So there is one cycle means 3 seconds. So one cycle, in one cycle there will be 3 seconds. So after completion of every 3 seconds, one cycle will be completed. With the 2 second on, 2 second will be on and 1 second will be off. 2 second, in the 3 second, 2 second will be on and 1 second, 2 seconds will be in the contracted states and 1 second it will come into the relaxed states. That's the meaning of this. Okay. So number of cycles per minute. So you know that in a minute there are 60 seconds. When you divide it by 3 seconds per cycle, so it will get 20 cycle per minute. The number of cycle per minute is 20 cycle per minute. That is 60 seconds is divided by 3 seconds, so that we get what you call as 20 cycle per minute. So in the case of 2 minutes, say I am talking about the high voltage electrodes, 80 seconds will be, so you know that totally there are 120 seconds. Totally there will be 120 seconds, that is 60 plus 60 seconds. In that 80 second it will be on off mode, and 40 second it will be in the off mode. That is 80 seconds it will be in the contraction state and 40 seconds it will be in the relaxation state. So there are total number of pulses is, so you know that 80 into approximately say 20 pulses per second. So we can, in some books we can find 15 to 20 pulses. Most of the times we go with the 15 pulses per second, or we can go maximum to the 20 pulses. So we get totally in 2 minutes approximately, in 2 minutes we get approximately 1600 pulses. So this is, even if you want, we can fabricate this and we can give you also. Okay. Coming to the types of electrical stimulations, low voltage, extra low voltage electrical stimulation. Whenever you use the current less than 100 volts, then it is called as a low voltage electrical stimulations. Okay. Then what is low voltage, extra low voltage electrical stimulation? Then low voltage electrical stimulation, or it is also called as medium voltage electrical stimulation. So normally 100 to 110 volts is the low voltage electrical stimulation or medium voltage electrical stimulation. This is the voltage we use it. Then whenever we use above 110 volts, it is called as high voltage electrical stimulation. Normally it ranges from 500 to 1000 volts. So normally they are using 800 volts or 1000 volts like. Okay, that is high voltage electrical stimulations. So we broadly, for easy understanding, we broadly classify into two: low voltage electrical stimulation, that is below 110 volts, it's called as a low voltage; above 110 volts, it is called as a high voltage electrical stimulations. So here also I forgot to tell one thing. Why we select this frequency is that lower frequency produce lower peak tetanic tensions. Okay, the tensions will be lower than the higher frequency. We can go at higher frequency, but maintain the peak tension for a considerable longer time. So lower frequency will maintain the peak tension for a considerable longer time. And the energy involved in the lower frequency is also low. So it will also not produce the heat of these electrodes that we use also. Okay, it will also not get heated, and the energy consumption is also very less, almost 1/7 of, we can say in the case of low pulse, that is around 9 to 15 or 20, it will be around, when you compare the energy, is 1/7 of that of the 100 pulse per second. So that is why we use the low pulse. And another thing is that if the pulse is above 20 seconds, like 20 seconds, the pulse will fall in the refractory periods. Okay, the pulse will fall in the refractory and it will not respond to the pulse. So the electrical stimulation will not be that much proper like. Okay, it will not bring the effect. So generally we recommend around 15 to 20 pulse, or it will be around 9 to 16 pulse. So different companies will having different pulse. Normally we recommend around 15 to 20 pulse per second is the pulse that we can use like. Okay, with one cycle which consists of 3 seconds, in which 2 seconds on and 1 second off. So coming to the difference between the low voltage electrical stimulation and high voltage electrical stimulation. The low voltage, as already told, the voltage applied is 100 to 110 volt. Even it can go up to 140 volts. The high voltage will be generally, the voltage applied is 500 to 1000 volts. Here it stimulates the nervous system, which then cause the muscle to contract. Okay, so it will be stimulating the nervous system. Here it will act directly on the muscle. The whole muscle is contracted. Here it is work mainly on the principle of nervous system. It stimulates the nerves, and the nerve innervated muscles will get stimulated. But here the whole muscle will get stimulated. Okay, so this should be done as quick as possible. So within 10 to 15 minutes we have to do the low voltage electrical stimulation, because as the time goes, the decay of the nervous system will be taking place and the stimulation will not be proper. And this is applied between 30 to 40 minutes, and most as quick as possible if you apply, that will be better. Used in small processing plants. Okay, these are normally used in a small processing plant. Here it is used in the high carcass throughput, where large number of animals are slaughtered. Then we go for high voltage electrical stimulation. Here it do not require elaborate safety system, because the voltage that we use is less. Here it requires an elaborate safety system. The safety system should be very proper, otherwise it can lead to electrical accidents. Okay, here the muscle contraction is very gentle. Here there is a tearing at the molecular level. So at the molecular level, because of the violent contractions and relaxation, the tearing of the tissues at the molecular level will also be taking place. So the capital cost is low, here the capital cost is high. So these are the difference of low voltage electrical stimulation and high voltage electrical stimulation. The high voltage, the voltage used is around 500 to 1000 volts, but normally we use around 800 to 1000 volts like. It will be acting directly on the muscles, so the duration, the lapse between the exsanguination and the application can go up to 30 to 50 minutes or 60 minutes like. Here it is work on the nervous system, so we have to apply within 10 to 15 minutes. So this is mainly used for the small processing unit. It is used for a high throughput. Do not require elaborate safety system. Here we are using high voltage. Naturally we require elaborate safety system. Yes, the general muscle contraction, there is a violent muscle contraction which leads to tearing at the molecular level. Capital cost is low, capital cost is high, and it is also labor intensive. This is labor intensive. For each animal we have to put this probe and do it, or we can go with the rub bars that I'll be discussing later. Okay. So procedure for electrical stimulations. Okay. When you are using the voltage, as I told you, the extra low voltage electrical stimulation, we have to do within 4 minutes. We have to give the electrical stimulation within 4 minutes of slaughter, and earthing is done through the anus or the leg region. We will be doing this. Okay. When we are using 80 volts, low voltage electrical, if we are using 80 volts means within 10 minutes of slaughter, that is immediately after the exsanguination, within 10 minutes, we have to do the electrical stimulation. Electrodes are kept in the muscle and earthing by the Achilles tendon, and we can do for 1 to 2 minutes. If we are using for 140 volts, we have to apply within 15 to 20 minutes. The electron is kept in the neck region or the spinal cord for around 2 minutes, and the earthing is done through the overhead rail. So how we are doing it? Okay, what is the procedure? Immediately after the exsanguination, we give the electrical stimulations. We have to give the electrical stimulations. So once you give the electrical, that is within, so normally in our meat plant we do within 10 to 15 minutes we give the electrical stimulations. That is before evisceration and before deskinning, we can do the electrical stimulations. Sometimes if it's a very stomach is full or it's a very large animal, sometimes we can find the rumen may rupture, but 99% we are not seeing such rupturing. So what is happening? So when you give the electrical accelerated postmortem glycolysis, so stimulating the innervated muscles, so it work on the nervous system. So nervous should be active. So as the time goes, the nervous will decay and it will not become active. So in the innervated muscles, it will stimulating the muscles. So there is a rapid fall in the pH, that is delta pH. So we have seen in the meat technology unit, the pH will from 7.1, it comes to around 6.5 like, okay. And further fall in the pH will take place within around say the pH of 6 will be attained around 1.5 to 2.5 hours. We can attain the pH, and then we can go for the hot deboning, and then it can be kept in the chiller without cold shortening. So let's see once again what is happening here. Just want to show you this stimulation was done little late, just for the demonstration. I'm just showing this one. So you can see the contractions of the muscles is not proper. So what are the signs? You can see the leg will be raised. Okay, the leg will be raised and it will become perpendicular, or it may be the forelimbs and the hind limbs will be raised. We can see here. Okay, and there will be flushing of the blood also taken. You must have seen the first one, the blood is oozing, that is electronic blood release, we can say that. Because of the violent contractions, because of the contractions of the muscles, you can see a lot of blood will be coming out. Okay, so that helps the bleeding efficiency can also be increased by the electrical stimulation. See, you can see the probe is kept here. Okay, probe is, so that is the individual animal we are doing this electrical stimulation. Next step is by the rub bar electrical stimulators. So this is mainly we do for the high voltage electrical stimulation. You can follow in the low voltage also, where the throughput is very high. Okay, where the throughput is very high. This is less labor intensive, but the capital cost is high. For higher volume, that is if you are slaughtering is throughput, if the number of animals slaughtered is more, then we go for this type of rub bars electrical stimulator. So you can see the bars is here, it is electrified, it will be electrified here, and the current will be passing and it will be stimulating the carcasses. For higher volume slaughter operation unit, which consists of single or multiple rub bars or continuous cabinet chain belt system are available. So this is less labor is involved, more faster and high throughput. So it will be fastly you can do the electrical stimulations at a time. Many animals can be stimulated. So the throughput will also be very high in this type of rub bar electrical stimulations. Now coming to the high voltage commercial rub bar electrical stimulations, whenever we go with the high voltage, we go with the rub bar electrical stimulators, because the high voltage is normally followed in where the throughput is very high, where the number of animals slaughtered is very high, especially in the New Zealand, Australia, in America also they are using this system also. You can see this is a relaxed carcass and this is a stimulated state. So you must have seen that clipping. In the relaxed carcass, you can see the foreshank or the forelimbs. You can see it is more relaxed or it's lying down. Here it is raised like. Okay, it will be raised like. And you can see the leg, it will be extended like. And there will be arching also will be taking place. Arching of the back will also be taking place. Okay, we'll see that one. Okay. So here, mechanical response to the stimulations, marked contraction of the back muscles. So there will be marked contractions of the marked contractions of the back muscles will be occur together with the rapid extension of the forelimb. That's what I told. Here you can see in the relaxed state it is like this, but in the during the electric stimulations there will be a rapid extension of the forelimbs. The extension of the forelimbs will be there. Notice upward movement of the foreshanks. So this foreshanks will be moving. You must have seen in the first clipping. This will be foreshanks will be moving up in a stimulated carcass within 13 seconds. So within 30 seconds, the forelimb began to become fatigue and swag. That is what we have seen in that second clipping. Slowly it will lose the extensibility, or the extension will be lost and it will become flaccid like this. This will occur in the case within 30 seconds after you apply the electrical stimulation. At the end of the 2 minutes, the stimulation, the muscle will still partially contracted. Okay, slowly it will be contracted. When the current was turned off, the carcass relaxed further to assume its original position. So when you switch off when you stop the electrical stimulation, it will come to this condition or this position. So it again the limbs will be became flaccid, like the forelimbs also became flaccid. This is what we can see here. Okay, the marked contraction of the back muscles. So here, see, normally when we do the study of the electrical stimulations, a single carcass will be split into two halves. So one side we give the stimulation, other side we don't give the stimulation. This is, I'm talking about the high voltage electrical stimulations. So one side we do the stimulation, other side we don't do the stimulation, and then we do the comparative study of the meat qualities and other parameters. Okay. So here it is a split carcasses. But normally we not recommend that one because it can lead to the rupture of the rib bones also. So it is not normally recommended. It is always better to, after evisceration, we can go, in the case of high voltage, after evisceration, we can, before the splitting, we can do this electrical stimulations. Okay. The marked contraction of the back muscles occurs together with the rapid extension of the forelimbs. That's what we told you. Site, the thoracic region. In the neck region, we can just, and earthing via Achilles tendons. So the earthing will be done on the top through the rails. Okay. So within 30 minutes is optimum. Generally, we can go up to 60 minutes, but optimum always, as quick as you do it, more will be the effectiveness of the electrical stimulations. So where high voltage electric stimulation is installed, where you can install it after evisceration, before splitting. That's what I told. After evisceration, immediately after evisceration and before splitting, you give the electrical stimulations. So normally in the big processing units, the stimulation, the splitting of the carcass, for splitting of the carcass after evisceration and before splitting, it will take around 25 to 30 minutes. So immediately after the evisceration, go for electrical stimulations. Okay. Yeah, it's called as a naked carcass. There is no hide and the offers. So all the internal organs are removed, hide is removed. Okay. So the resistance will also be less and the efficiency of electrical stimulation will be better and no chance of ribs breaking. So if you do the whole carcasses, there is no chance of ribs breaking, or sometimes we can come across if you are splitting and doing means there is a chance for ribs breaking. So always it is advised to install the high voltage electrical stimulators between the evisceration and splitting. So you can see here the result depending on the time from stunning. Okay, up to 50 minutes it is giving very good results. After 50 minutes it's a good results and it is a weak result. Oversight. So optimum is within 30 minutes you try to do it. So that will give a better result or reduction in the muscle pH. What are the advantages of electrical stimulation? Cold induced toughening is reduced. That is, cold shortening will be reduced. So that will favor the hot deboning and rapid chilling can be followed. And the studies show that it improves the tenderness up to 30% tenderness is improved compared to that of non-stimulated meat. Postmortem aging time, that's what I told. Postmortem aging time could be reduced to 1/4 to 1/6 if the electrical stimulation is reduced. See, normally, if it is take the complete aging, if it takes around 14 days means we can do it in 1 or 2 days. We can do it. So it will be more economical also. So what are the other things we can see? This is the electrical stimulator. This is non-electrical stimulated rib eyes you can see. Okay, this is a rib eye. This is a rib eye. What are the things we can? It is brighter colored. The bright color is very important because the meat color is important quality trait uh, to the consumer's decision at the point of purchase. If the bright color or cherry red color or the bloom we call as, if it is more brighter or cherry red in color, the consumer will prefer it more. Okay, so this is the color is one of the important factor at the point of purchase. So it gives a bright color. Next is it gives firmer and finer texture. It gives a firm and finer texture, and it is also the marbling will also be increased, or the visible marbling will be become. The marbling become more visible when you do the electrical stimulations. These are the advantages of electrical stimulation. Again, we can see what are the. It reduces the incidence of heat ring formations. So heat ring formation will be reduced. What is heat ring formation? I will explain you later. Then the brightens the muscle color. That's what you can see here. It is more bright in color or cherry red in color compared to this one. Increase the muscle firmness. We already discussed it. It will become more firm. Improve marbling and retail cut appearance and shelf. It also extends the shelf life also. It keep longer. That is, we can keep for longer time than compared to not of non-stimulator, and shorter cooking times. It will be more tender, and it also reduce the cooking time. Promotes better flavor also, improves the bleeding. That's what electronics bleeding we talked about. Okay, you must have seen in the clippings, the blood is less flushing out. Okay, during the stimulation, the blood is flushing out. So it improves the bleeding also. Around 1 to 1.5 liters of blood eliminated from the carcass will be more than compared to the non-stimulated one. Eliminating the need for costly aging. It also reduces the cost of aging. How we'll be discussing that later. So coming to the economics of electrical stimulation. So actually, I can say that electrical stimulation is a boom for the meat industry. So it is actually a boom for the meat industries because tenderness obtained after electrocution followed by 1 day aging is similar to that of 14. So the effect that we get in 14 days of aging, we'll get it just in 1 or 2 days. So since we are getting in 1 or 2 days, no need to keep for chilling for a long, or in the aging room for a long duration. Because if you want to keep it, we have seen it, if you want to keep it for the aging for a long duration, means the cost of electricity will be more, labor involvement will be more, the throughput will be reduced. Okay. So that is, and another advantage I found is most of the studies shows that drip loss in the chiller room is 1 to 1.5% less in electrical stimulated carcass than in the non-electrical. So 1 to 1.5 means it's a big value where the number of animals slaughtered is more. So suppose if you take one animal, suppose it's 300 kgs, you just assume that. So if you take the drip loss, 1.5% is less. So in the case of 300 kg, how much we'll get it? We'll get it around 4.5 kg more meat. So suppose I'm slaughtering around 100 kg, means around 450 kgs I will get more. So that is the advantages of electrical stimulation. So in the long run, it will be very economic. Another thing is stronger contraction detach the meat from the bones easily. So because of when you do the high voltage electrical stimulation, the muscles will get detached from the bones easily. So it will be easy for deboning also. So the person involved in the deboning, for them it will be very easy. So the work output will be more. And not only that, it makes the meat more spongier or loose. I told you high voltage electrical stimulation, when you give it, the internal structures of the muscle, at the molecular level, there is also breakdown of the structure. So it will make the meat also to become spongier. So we can see here, within 1 or 2 days, we can achieve the tenderness similar to that we achieve in the 14 days. The cost of chilling is reduced. The cost of capital, the labor cost, everything can be reduced. So this is actually the boom for the using of electrical stimulation is the boom for the meat industry. So this is the study. We can see this. If you want, you can just observe this one. Different parameter, different low voltage electrical fast chilling. They studied with the different thing, and they found that the aging that we attain in 14 days can be attained in 1 or 2 days. That is the main advantage. The aging qualities we attain in 14 days can be attained in 1 or 2 days. So it is actually a boom for the meat industries because it reduces the cost, but at the same time it will increase the consumer sensory qualities. So let's understand certain questions. the best time to do the electrical stimulation. So in the case of low voltage electrical stimulations, if it's a extra low voltage electrical stimulation, we have to do it in 4 minutes or within 10 minutes like. Otherwise, the low voltage electrical stimulation we can do within 10 to 15 minutes, or maximum we can go up to within 20 minutes. In the case of high voltage, it is also we have to do within 60 minutes, but optimum I say is around 30 minutes is most optimum. Which is better, low voltage electric stimulation or high voltage? Naturally, the high voltage electrical stimulation is giving, most of the studies shows that high voltage electrical stimulation is producing more tender meat, but the problem is high safety measures is required. So this capital investment is also very high. Like, why electrical stimulation is not done in the, normally it is not done in the peaks? Why we will not follow the electrical stimulations in the case of peaks? Because there is a rapid decline in the, when you give the electricity, there is a rapid decline in the pH, and this will produce a condition similar to that of the pale soft exudative in the peaks. That is why it is normally we don't do electrical stimulation in the case of peaks. Why it is advisable to do electrical stimulation immediately after slaughter? That is freshly slaughtered carcass. Why it is advised? That is within 15 minutes in the case of high voltage. Okay. Because as the time goes, the nervous system will decay, so the response to the stimulation will also be reduced. That is why we always advise to do as quick as possible. So what is heat ring? This is mainly seen in the carcass with a low level of external fat. If the external fat is very less, say less than 0.64 centimeter, the outer of the ribeye area, this mainly seen in the ribeye area, the outer ribeye area will chill very rapidly, because if the fat is there, it will act as an insulator, so the heat will not pass, or the coldness will not come faster. But since the external fat is very less, it will chill very fast. So you know that chilling takes place from exterior to the interior, from outside to inside the chilling will be taking place. So from first this will be chilled, then it goes like this. So this will chill very fast. Okay, since it chills very fast, what happens? The pH fall will be less, because you know the rigor mortis is directly proportional to the temperature. If the temperature is high, the pH fall will be faster. So here you know the temperature is high compared to here, so the pH falls here, it will be faster. So here the high pH, here the low pH. So because of variation in the pH, we will get as two distinct colors. Okay, inner will be more brighter like, outer will be darker in color. Okay, this is a longissimus dorsi muscles. Inner will be somewhat more cherry red in color, outer will be dark in color. So this is called as heat ring. So when you give the electrical stimulations, this heat ring formation can be prevented, or it can be reduced. So what is the problem with the heat ring? So when the consumer buy, it does not give a good appeal to the consumer. That is why the heat ring should be prevented. By giving the electrical stimulation, we can prevent the heat ring, because it will utilize, the pH fall will be almost same. Outside and inside will be almost same, and the color formation will be almost same. So there is no any defect we can see, like, okay, visual defects we cannot see. That is the advantage of electrical stimulation. So electrical stimulation prevent cold shortening. So for cold shortening to occur, two things are very important when pre-rigor meat, that is the meat in which, or in the muscle in which the rigor has not started, onset of rigor is not there, and the pH is more than 6. When such pre-rigor meat is exposed to temperature less than 10 to 15 degrees centigrade, there will be a shortening of the muscle will take place, because at the temperature of around 10 to 15 degrees centigrade, there will be sufficient ATP. At the pH above 6, there will be more ATP will be there, and when you expose to temperature of 10 to 15 degrees, the sarcoplasmic reticulum will lose the calcium. So the two component that is required for the muscle contraction is sufficient. So that leads to the muscle contractions or the cold shortening. But when you do the electrical stimulation, there is a rapid fall in the pH. So within 2 minutes or 4 minutes, the pH will fall to around 6.5, and further reductions in the pH will also take place rapidly. So then at the pH of around 6 can be attained around 1.5 to 2 hours. Then if you keep it at a temperature of 10 to 15 degrees centigrade, it is not going to have the cold shortening because there is no sufficient ATP. That is how the cold shortening can be prevented by using electrical stimulations. So thank you very much for listening to this class.